Okay, let's get into it. We've all heard that Red Hat OpenShift is, the enterprise Kubernetes heavyweight. But what's really under the hood? Today we're going to pop that hood and look past the marketing to see what actually makes this engine tick.
Exactly. Our whole goal here is to give you a real shortcut to understanding the architecture.
Hmm.
We're going to dissect the main parts, the control plane, the worker nodes, networking, security, to really see how it gets that reputation for being so hardened and automated.
Great. Let's start with the big picture, though, the brain and the muscle. OpenShift has this clear separation between the control plane and the worker nodes. And if you're building a cluster, that difference is, well, fundamental.
It is. And what's really fascinating is the redundancy they build into the brain, the control plane. It manages everything. The two components you absolutely must know are the API server,
Which is the single entry point for everything.
the only entry point, yeah. And then there's et cetera. That's the cluster's distributed database. And the main takeaway here is just sheer redundancy. No single point of failure is going to bring your cluster down.
Okay, so if that's the brain, then the worker nodes are where the heavy lifting happens. That's where your applications, your pods actually run. They use the kubelet to talk to the brain, but they also need a container runtime. You mentioned CRIO, so for a developer who's maybe used to Docker, what's the practical difference there?
That's a great question. CRIO is it's a much leaner runtime. It was built specifically for Kubernetes. So unlike Docker, it strips away a lot of the extra features that developers might use on their laptops. This makes the worker nodes way more efficient. They're just focused on one thing,
Yeah.
running containers at scale.
Right, efficiency. That makes sense. Now let's pivot to what might be the biggest value proposition here. Security, we hear about it all the time. But what's the concrete value? I mean, standard Kubernetes has RBAC, role-based access control. What does OpenShift's enforcement of CLNX and these security context constraints or SCCs, what do they actually stop that vanilla K8s doesn't?
They stop lateral movement and privilege escalation, dead in their tracks. So while RBAC is about who can deploy what, SECs are about how that deployed container can behave at the kernel level. And here's the key detail. By default, containers run with incredibly restricted permissions.
So if a vulnerability gets exploited.
Exactly. The container can't just start snooping around the host kernel or trying to escalate its privileges. It's locked down from the start.
Okay, so with all that heavy lifting happening internally with CLNX, how does it handle the other side of the coin, getting external users to our applications?
Right, that's networking. OpenShift introduces a concept called routes. Think of a route as basically the easy button for ingress.
The easy button, I like that.
It's an OpenShift-specific thing that lets external traffic find your application without you having to manually configure your load balancers or anything complex. It smooths out that whole journey from code to public.
And that seamless experience seems to carry over into the developer tools, the web console, the Akka command line tool.
Oh, absolutely. And that focus on developer productivity is where OpenShift really pulls ahead.
Yeah.
Beyond integrating with CI/CD tools like Tekton or Argo CD, its secret weapon is probably source-to-image S2I.
Explain that. What is S2I?
It lets you just push your raw application code, say, from a GitHub repository. And OpenShift automatically and securely builds a container image and gets it ready to deploy. It completely simplifies the build pipeline.
So we're not talking about Docker files anymore.
You don't have to, no. It's why GitOps works so well on the platform.
And what about for stateful applications? Databases, message queues, things that need to store data. We have persistent volumes, PVCs, storage classes. How do you explain that win to someone?
It's about guaranteeing that your data will survive. It decouples the application from the data's location. The storage class abstracts the underlying cloud storage, AWS EBS, Azure Disk, whatever it is.
Yeah.
So even if your application's pod dies or moves to another node, your data is safe and gets reattached automatically. It's resilience.
So, to wrap this up for everyone listening, what's the big takeaway? OpenShift seems to be the enterprise choice because it offers this hardened, secure by default version of Kubernetes, and it's all wrapped up in a package that actually makes developers' lives easier.
That's it, which brings up a really important question for you to consider as you go forward. Since OpenShift mandates such strong controls like Linux enforcement and these really strict default permissions, what kind of friction or challenges might that create when you try to migrate older legacy applications onto the platform? Applications that were never designed to run in such a lockdown world, something to mull over.